So hello everyone again. This is lecture number 1 part 3 of ray optics and optical instruments. Today we will move on with the discussions of deriving the mirror equation. So let's not waste any time. I am Sameer Lavankar. Let's begin our discussion. Okay, so right now we are on the second part, that is the reflection of light by spherical mirrors. So before that we just started with the introduction of why is the ray optics necessary, what was the difference between ray optics and wave optics, and the basic law of reflection. What is the basic law of reflection was being dealt in reflection of light by spherical mirrors, what is the focal length, what is principal axis, etc. were being dealt. So right now we are on the portion to derive the mirror equation. So let's move on with the mirror equations derivation now. So first of all, let us try to explain, let us try to understand basic parts here. So if the rays emanating from a point actually meet at another point after reflection and on refraction, that point is called as the image of the first point. So in the previous lecture I explained you using diagram of what is the image of the first point. Okay. Next is if the image is real, if the image is real if the rays actually converge to the point. What does it mean by image is real and image is virtual? So let us suppose, let me use the diagram for the previous cases only, so that will be easy. So as you can see the diagram here, as you can see in the diagram here that these are the rays which are being incident at this point. So you can see quite evidently that this can be the point at which the image will be formed, because the real rays are being used. What is happening here? Here the real rays are not incident at this point, or they are not coincident at this point. These are basically, if we understand these to be emanating from a virtual position, hence this is called as a virtual image. So this is a basic example of a real image, because real light is being used. Here no real light is being used, all are virtual lights. As you can see, dotted lines are being used here, hence this is an example of virtual light. Okay, let us move on. So the image is real if the rays actually converge to the point. If it is virtual if the rays do not actually meet but appear to diverge from the point when produced backwards. This was the only example which I tried to explain in the previous discussion. Okay. An image is thus a point to point correspondence with the object established through reflection and on refraction. Quite evident it is a point to point correspondence. So if the image height is like this, every point is being incident at if every location or the on the mirror, and then an image is being formed like this. Okay. So in principle we can take any two rays emanating from a point on an object, trace their paths, find their point of intersection, and thus obtain the image of the point due to reflection at a spherical mirror. Quite evident. So even if you take, let us suppose for an example, this is the mirror, this is the principal axis, this is the height of the object. If you take one ray of light like this, you take another ray of light like this, you can find out the value of height of the image. So that is the only thing which we talked. So this is one of the light, this is second light here. Okay. So in principle we can take any two rays emanating from a point on an object, trace their paths, find the point of intersection, and thus obtain the image of the point due to reflection at a spherical mirror. Quite evident. So this was the only data being talked about here. In practice, however, it is convenient to choose any two of the following rays. What are the two following rays being talked about? The first is the ray from a point which is parallel to the principal axis. So this has been talked about here. The reflected ray goes to the focus of the mirror. So this, let us suppose this is the focus being talked about here. The next is the ray passing through the center of curvature. The ray passing through the center of curvature of a concave mirror or appearing to pass through it for a convex mirror. The reflected ray simply retraces the path. So that's the second point which is it trying to say is basically if you try to use it using the center of curvature. So what will happen is basically, let us suppose I make that point here, let us suppose this is that center of curvature being talked about here. So what will happen is basically it will go and retrace the path. So basically it will go in this direction and then it will move in the same direction. So basically you can find out that image here. Let me make the diagram much more clearly so that this thing is understood. So let us suppose this be the center of curvature. So basically a light which is incident in this portion will return back or retrace the same path. The second is that let us say this is the incidence of light, it will pass through the focus. So, basically this is the reflected light, these both rays of light join at this location. So, basically this is that image. So, this is that object and this is that image. As you can see clearly that the image is real, also it is inverted. Okay. So, these are the two rays of light being talked about here. Let us move on with the further discussions. Okay. The rays passing through or directed towards the focus of the concave mirror or appearing to pass through or directed towards the focus of a convex mirror, the reflected rays parallel to the principal axis. So, this is the third point being talked about. So, basically what is happening, what is the point being talked about here. So, we can take either this ray also. So, let us suppose this is that height of the object, let us suppose this to be the focus. So, if we are taking an incident ray such that it is like this, then this ray will pass, which or this ray will be parallel, the reflected ray will be parallel to the principal axis. Okay. So, this is the third point here, the ray passing through or directed towards the focus. So, as you can see this is directed towards the focus of the concave mirror or appearing to pass through or directed towards the focus of a convex mirror, the reflected ray is parallel to the principal axis. As you can see the reflected ray is nothing but parallel to the principal axis. Okay. Fourth is the ray incident at any angle at the pole, the reflected ray follows the laws of reflection. So, the third last point was that even you can take this has been drawn here. So, this is that point. So, as you can see this is incident at pole and then angle of reflection were being dealt apart. So, this is angle of incidence, this is the angle of reflection. Okay. So, this thing has been done, this thing has been done. Next, so basically these are the 4 points. So, any of the two rays can be dealt apart. So, choose any two rays, two of the following rays. Okay. So, I guess they have made every ray. So, this is that first ray here, this is that second ray here, the third ray is not being drawn. So, third ray can be basically, if I make a ray like this, so this is that third ray and this is this fourth ray. So, these are the four rays, any of the two can be chosen depending upon the criteria, depending upon the observations, and then the questions can be dealt or basically the image can be formed. Okay. So, figure shows the ray diagram considering 3 rays. So, here only 3 rays are being considered. It shows the image A dash B dash. So, this is the image A dash B dash being formed here. In this case real, quite evident. Why it is real? Because real lights are being converging at the portion. Okay, of an object AB formed by a concave mirror. So, this is object formed by a concave mirror. Okay. Next is, it does not mean that only 3 rays emanate from the point A. Quite evident, there can be many rays. There can be many rays which are emanating from this portion, but they are reaching the same location, which is point A. Okay. An infinite number of rays emanate from any source in all directions, but for geometric purposes these 3 rays are those 4 rays are easy to understand, they are easy to make up. We know exactly know the value at which they will intersect. Why? Because then let us suppose I take some vague ray, then I need to calculate first of all this angle, so that this angle what it makes, then I will try to equate, I will try to use the exact same angle which it passes through, then the task increases, the tedious task increases. So, to reduce that tedious task what we do is we take basic equations. So, basically we do like this, pass through it focus, we take through the center of curvature, pass through, retrace it back, we take it to the focus, take it parallel, we take it to the pole, we make the angle of incidence. So, basically these 4 rays are easy to make up, they take less time to make up, that is why we use these 4 rays. Okay. So, an infinite number of rays emanate from any source in all directions, thus point A dash is the image point of A if every ray originating at point A and falling on the concave mirror after reflection passes through the point A dash, quite evident. So, thus point A dash is nothing but the image point of A if every ray originating from this portion and falling on the concave mirror. So, it is falling on the concave mirror after reflection. So, after reflection passes through point A dash. So, this is the basic explanation, this is the basic reflection concept only, there is nothing typical in it. Okay. We now derive the mirror equation. So, now very basic, very important equation for this complete chapter called as mirror equation. So, we now derive the mirror equation or the relation between the object distance u image distance V and focal length f. So, what are the denotions here? So, please remember this. First is object distance u, next is image distance v, next is focal length f. Okay. So, from the figure, the two right angle triangles A dash B dash F and MPF are similar. What are these triangles? So, as you can see, A dash B dash F. So, basically this is the first triangle. Let me choose different colors. Okay, so these both triangles are similar for the basic concept of basic assumption that there is a para-axial. We have understood that MP can be considered to be a straight line. Straight line as it is perpendicular to CP, the principal axis. Okay, so from the figure, the two right angles A dash B dash F and MPF are similar for para-axial rays. MP can be considered to be a straight line perpendicular to CP. Therefore, B dash A dash upon PM. So basically, what is it this? So, this is B dash A dash upon PM up is equal to B dash F upon FP. Quite evident, these both are bases, these both are heights. So, basically a ratio of the heights is equal to the ratio of the bases. So, B dash A dash is equal to upon MP is equal to B dash F upon FP. So, this is the first equation. Okay, fine. Next is so just iterating it. So, what is here? So, this is PM, where is PM? PM is this. So, this PM can be said as equal to this AB, because both are of the same height. Hence, we can just write B dash A dash upon BA is equal to B dash F upon FP. So, this is the first equation being dealt here. Next is then since angle APB. So, which is the angle APB? APB. So, this is that angle being talked about here, angle APB is equal to angle A dash PB dash, A dash PB dash, quite evident using the simple laws of reflection, that is the angle of incidence I is equal to angle of incidence R. We can say that angle APB is equal to angle B dash PA or A dash PB dash. The right angle triangles A dash P dash P and APB are also similar. So, just let us move on with that symbol now. So, second thing is that A dash B dash P. So, A dash B dash P is this triangle. Let me choose different color. And ABP. So, these two are the triangles again, they are similar to each other. Therefore, what we will do is again B dash A dash by BA. So, B dash A dash by BA, so that the ratio of the heights is equal to B dash P by BP, B dash P by BP, the ratio of the bases. Similarly, comparing the two above equations. So, let us suppose this is the first equation, let us suppose this is to be the second equation. Therefore, what we can write? We can write B dash F upon FP. So, B dash F upon FP is equal to B dash P minus FP. As you can see, quite evident, you can see from this result here that B dash F, what is this B dash F? B dash F is this portion here. This is equal to B dash P. What is B dash P? B dash P is this minus FP. Quite evident, as you can see clearly. This is equal to this minus this, which is equal to B dash P by BP. B dash P by B dash P by BP. Where is BP here? So, this is nothing but ratio of, as you can see from this portion, B dash F upon FP is written here and B dash P upon BP is being used as both are equal. So, basically if this is equal, so equating these two equations we can find that B dash F upon fp is equal to b dash a dash upon ba is equal to b dash p upon bp. Therefore, this thing has been written here, this thing has been written here. Now, above equation is a relation involving magnitudes of distances. So, now we apply the sign conventions now. So, now sign conventions are to be applied. Please look over here carefully, because where to use the negative sign, where to use the positive sign is very needed apart. Okay. So, now we know that a light travels from the object to the mirror MPN. So, basically the incidence of light in this is in this direction. Hence, this is taken as positive direction, quite evident, because this was the Cartesian sign convention. To reach the object AB, image A dash B dash as well as the focus F from the pole P, we have to travel opposite to the direction. Quite evident, as you can see, all these incidence lights are in the opposite, or in the is in the direction which is opposite to the direction of incidence of light. It does not depend that it has to be parallel only. If the incidence is like this, it can be considered like this in any direction. Just the point is that it is opposite to the direction of incidence of light. So, therefore, hence all the three will have negative signs. Therefore, B dash P. So, B dash P will also be negative. So, this will also be negative. So, this is the image distance. Why? Because the image is being formed at this portion. Next is FP. FP is also minus F. Why? Because it is in opposite direction of the incidence of light. And similarly, BP is also minus u. What is BP here? BP is this portion here, which is equal to minus u here. Why minus? This is the object distance, that is the distance of the image, or sorry, the distance of the object from the pole of the mirror. Okay. So, just using the equations, so just derive putting every value in this equation, what we will get? We will get minus v plus f, matlab minus v minus f, minus v. So, just deriving the equation here for you. So, it is minus v minus f upon minus f is equal to minus v upon minus u. Therefore, what we will get? Minus v plus f upon f is equal to v by u, or we can get equal to, there will be minus sign here. Therefore, what we can get is nothing but v minus f upon f is equal to v by u. So, just writing this as v by f minus 1 is equal to v by u. Dividing the complete equation by capital V, we will get 1 by f minus 1 by v is equal to 1 by u. Therefore, just using simple mathematical formulation, we will get 1 by u plus 1 by v is equal to 1 by f. So, this is the typical mirror equation. So, just simple mathematical formulation will derive you that 1 by v plus 1 by u is equal to 1 by f, or we can just say that this relation is called as the mirror equation. So, basically the derivation is nothing but that the reciprocal of the image distance plus the sum of the reciprocals of the image distance and the object distance is equal to the reciprocal of the focal distance. Please make sure when you are trying to derive the formula here, when you try to analyze the questions here, you just need to understand when you need to use the negative sign and we need to use the positive signs. I think I explained 2-3 examples regarding the mirror equation. Please look over them very carefully. For now, let me end it here only. So, in this equation, in this complete chapter, in this complete lecture, everything which we understood in the mirror equation has to be used in the subsequent slides, it has to be used in the subsequent lectures. So, please look over carefully, please understand the complete sign conventions very carefully, revise it again and again, because even if the paper comes with mirror equation, only and only thing which you can make an error is just the mirror equations sign conventions. So, let me stop it here. So, the final derivation or the final conclusion of this chapter is that the mirror equation is 1 by v plus 1 by u is equal to 1 by f. Okay. So, let me stop it here. Thank you so much.